Okay. Okay, welcome to Google Cloud Platform Online Meetup number 6. My name is Jonathan Cham. I'm a customer engineer here at Google, and I want to introduce you to the lovely and handsome Mr. David Wynn here.
I'm so glad we don't have the camera turned on. I have a face built for radio. Hello, everyone.
So we are talking about the next Hadoop, Cloud Dataflow for mere mortals, and I think we purposely titled that because Cloud Dataflow has, I guess, traditionally been a little, what do you say, scary.
I think it's scary, yeah.
Yeah. And when I first looked at it, I think for someone who knows traditional big data, you think about, what do I need to do to set up big data? When I went to the documentation for Dataflow, it was just straight up API documentation. And at first I was like, oh my gosh, what is this? What am I getting into? But the more you learn about what Dataflow is, the more you realize that it's actually simplifying your life tremendously. So I think that's what David here is planning to talk about.
That is the goal.
That is the goal. So David, let's get started.
All right.
I mean, I'm excited. I'd love to hear what you have to say. I would love for the listeners to say something on the online chat. Make sure we're loud and clear, and make sure that these are actually real viewers and not bots watching. But
I wouldn't mind bots watching.
Actually, if it was bots, I think that'd be really cool.
Yeah.
And we'd be a little more, we'd have a little more fun talking about things that are not related. But yeah, send us a message on the live chat, because I don't know if we're coming across.
We don't know if our audio is working.
Yeah. So say something. And I will actually send a note saying, if you can hear us, say something. Or at the airport, they say, if you see something, say something.
Yeah. So if you hear something, say something.
Yeah, exactly.
Yeah, I like that.
All right. So yeah, let's get started, David. I'm excited about this.
All right. With that, we will go ahead and jump in. So thank you very much, Jonathan. For those that do not know me, hello, my name is David Wynn. I am also a customer engineer on the Google Cloud Platform. It's obligatory that I say apologies for last time. We learned an important lesson at our last attempted meetup meeting, which is that running beta software does not always work if you need to do a webinar. And we've written that, everyone knows that lesson, but we've really learned that lesson this time. So today we're back on stable, we're feeling good, we're gonna get to go.
Nice.
Now
David's very ambitious, by the way, which is why he's always running alpha software. But to everyone listening, running alpha software in production, not a good idea.
Not always what you would hope. That's true. So we've titled this presentation Dataflow for Mere Mortals, because as Jonathan was saying earlier, I think that Dataflow can be a little bit intimidating for some people who may not be familiar with the abstractions, for some who are just hearing about what it may be and what it may or may not do, and it's not totally clear how it's different from other data processing frameworks. So what we're going to talk about today is a little bit of the history of where Dataflow comes from, as well as the absolute basics, ground level stuff that you can use to get off the ground and start playing around with your own pipelines inside of Dataflow. So give me a sense of the agenda. What we're going to take a look at is, like I said from the start, where things came from. Then we're going to talk about Apache Beam. And the spoiler alert there is that Dataflow and Apache Beam are the same thing. Dataflow is just an implementation of Apache Beam. How to use it, and then we will actually run through a live demo, because it wasn't enough just to get this webinar up and running. We got to make sure that we have a live demo, so we add some more risk to it. So we'll be doing all of those things. I'm going to start at the very beginning. Computers are great, right? One of the things that computers have always been exceedingly good at, and what we've always asked them to do, is to process data. And over time, as our expectations of them grew, we started to add more and more data on top of it. And it starts to get to the point where the data we want to do doesn't fit anymore on one machine. And then sometimes it really doesn't fit anymore on one machine. And many people have termed this the era of big data. Now, there are a number of different definitions of what you might actually mean by big data. Some people talk about standard tooling. Others, what the definition I'm going to take today is that big data is when you are trying to get a tackle around a data processing problem that doesn't fit on one machine anymore. So instead, maybe you want two.
Yeah, I mean, you can only scale up so much, right?
Yeah.
You can only add so many CPUs, so much memory, and at some point, vertically scaling up. Yeah, at some point, you're maxing out.
Right. So as we scroll up to 2 machines, maybe some sort of power of 2 machines, if you happen to have an entire data center or something else at your disposal, we now have different opportunities in terms of what we can process with data. Now, ideally, you would want to take some sort of workload or some task at the top. You would want to distribute that out to all the machines, have them run some sort of processing job on it, and then get the answer out at the bottom, whether that would be a transformed data set or some form of aggregation or something like that. Now, Google ran into this problem a long time ago. We published the MapReduce paper in 2004.
Yeah. I think a lot of people, so when I present to a lot of customers, when we remind them that MapReduce is almost 10, 12 years old, they're like, wow. And now it's like the big thing, right? Hadoop.
Yeah.
So we're I think I forgot one of the big data people, I think they said, Google is kind of running 10 years ahead of us. I forgot who that person was, but and it's true. And I always remind people, it's not because we're cool. It's not because we want to. It's because we have to, right? When we support 1 billion users, 8 billion across 8 different apps, you have to do things completely different, or else we're not going to scale the way we want to.
Mm-hmm. But it was we released that paper a long time ago, and it was a paper called MapReduce, which I'm sure many people on the live stream are familiar with. But to give a brief overview, you can break down MapReduce into 2 different segments. On the one hand, when you create a MapReduce job, you write a map function that filters and or sorts your data. On the other hand, you write a reduce function that performs some sort of summary operation on top of it. Now, many people are also probably familiar with the idea that there's actually a third step to this process, the shuffle that occurs in between them, because you generally do this on different machines, and you have to get all of the data that's been sorted and filtered to different machines in order to reduce it. And that can be a potentially big overhead depending on the pipeline that you're building and the different types of operation that you're trying to perform. But that said, it's a great tool. We absolutely beat it to death here at Google for a long, long time. And what we learned over time is that there are some faults with the MapReduce paradigm. And to walk you through an example of that, I'm just going to take you through a clickstream analysis example. So if you were trying to understand a clickstream a little bit, one of the things that you might want to start with is some logs of clicks, and you would parse them into meaningful values. You would extract those timestamps for each of the different clicks so that you could group them up by client. You'd then calculate session times so you could figure out how close together are these clicks, and do we want to consider that one session, or do we want to break them out a little bit further? You could do that dynamically. You could do that with bounded windows. You could do that with fixed windows, whatever makes most sense to you. You can extract the query terms by client, and then at the end, you want to merge them all together. So really what you want at the end of the day is you want to know the query terms by client that led to the greatest session times, right? That's a pretty standard thing you would want to get to. But if you are coming at this strictly from a MapReduce paradigm, you might struggle to figure out exactly how this is going to map from problem set into solution set. Because MapReduce, as effective as it is not always the most intuitive paradigm that we could use. And so having come across this, Google decided to build something different. And this is where we enter with Apache Beam. And once again, for those paying attention, Apache Beam is the open source version of Cloud Dataflow. So Dataflow is just our managed Apache Beam runner, but all of the things you would write if you were using Apache Beam would be Beam pipelines.
So Apache Beam is the open source, I guess, the open source API modeling, right?
Yes.
Yeah.
So it is the software and the framework in which you would write in order to build pipelines for Dataflow.
Right. And we learned, I think, last week that there's multiple runners that can process your Apache Beam job.
There are, and we'll see those later.
Perfect. You're ahead of me.
Now, if we pulled the definition of what Apache Beam actually is, which once again is just Cloud Dataflow, from their website, you would get the following. Apache Beam provides an advanced unified programming model, allowing you to implement batch and streaming data processing jobs that can run on any execution engine. That is a lovely definition. I'm sure it's very precise and it means a lot to somebody. But
it sounds like marketing speak, to be honest.
I mean,
and that's a really cool logo, by the way.
Yeah, that's the beam logo. I like it.
That's cool.
Just look at the beams going to the left. It still makes a B. Yeah, it's clever. I wanted to take a stab at what I hope is a more meaningful definition.
Yeah, I appreciate it. Dumbing it down for people like me, I mean, there's a lot of fancy words here. Unified programming, batch streaming, execution engine, processing jobs.
I prefer the term distilling to the essence.
Yes, for mere mortals.
So here's my attempts to describe what Apache Beam will get you. And I will use the terms interchangeably, so I apologize if I switch back and forth. Apache Beam allows developers to intuitively write data processing pipelines so they can focus on solving their problem rather than tweaking their tooling. And as simpler and as more focused as that is, that doesn't still quite give you the specifics of what we're going for. So I'm going to highlight 4 key benefits from writing your data processing jobs in Apache Beam. Number 1 is the design aspects of writing in Beam. So instead of focusing on functions, one of the things that Beam allows you to do is to build a directed graph for all of the different data that models to your problem. So you can take it from start to finish and tackle the whole problem at once. This not only allows you to keep your head in terms of where everything is going, you also don't have to mess with intermediate values. You can, but you can also create more complicated relationships in terms of pulling in data from different sources, sideloading them out in different capacities. There's a lot of different flexibility that you can get with going from a graph-based approach. The second aspect that's helpful with Apache Beam is the developer experience. So I am making the claim here today, and I admit this only may apply to me, but I find that writing in Beam is much more intuitive than trying to go straight with MapReduce. Not only because you get to write things more concisely, Beam is written at sort of a higher level of abstraction so that you can much more cleanly describe these problems, but it's also easy to test your pipelines locally before you run them on any sort of remote or production runner. So we'll see what that looks like a little bit later too.
I don't know if this makes sense to ask this, but Richard had asked about data flow as opposed to Spark. Is that something you might cover later?
So there's a lot of different angles to the Spark question.
Right. I mean, Spark by default, I think implies that you're going to create your own cluster, set up Spark. I mean, there's still a lot of operational aspects to that.
So let's leave the management aspects aside, because I think what the question is getting at is sort of the development experience. And I will say that Spark is definitely moving in a direction that is sort of very inspired by a lot of different influences, and some of the ideas came from Apache Beam. We do have an article that talks about earlier versions of Spark compared to Dataflow and some of the different compare and contrasts associated with them. My understanding is that the current big difference that still exists has to do with windowing and timestamping with dealing with streaming jobs, and also some of the syntax and some of the primitives are a little bit different. But you will be able to do some of the same things inside of Spark. The goal for Beam is really to and I even have a slide for talking about that. Yeah.
You're on it.
Trying to make sure I know what I'm talking about. I see what you're doing there. Anyway, to go into an example of why the developer experience can be more intuitive with Beam, I want to return to the clickstream analysis.
Yes, please.
So we've got the steps here: parse the logs, extract timestamps, calculate session times, et cetera, et cetera. One of the things that is meaningful that you can do in Beam is basically you map those one-to-one to functions. So we'll talk a little bit more about what these different functions are in just a minute. But suffice it to say that you are mapping, so you're literally applying a function to all of those different values inside of your collection. And you're doing that along with some group by keys in a very sort of one-to-one intuitive way. You could probably achieve this in other paradigms that I'm less familiar with, but it's a very straightforward mapping here in order to make this happen. Benefit number 3, the machines can do a lot of the optimizing for us. So because you are building a graph, it is essentially a statement of intent of how you want your data to flow. And in that regard, the machines can take what you've written and then re-optimize that for how the machines actually process what's going on. And the best example of this is with associative relationships. So if you, at the end of the day, want to do a count or a sum or something that can be associatively defined, what the runner for the pipeline can actually do is take that instruction at the bottom of the pipeline and pull it up the stack so that as soon as it gets the individual atoms of data that it needs to sum, it can start summing them on whatever machine extracted them, rather than having to extract everything, shuffle, get intermediate value, shuffle again. It can pull that all the way up, so you get orders of magnitude more efficiency as it distributes down the pipeline. And it does all that for free. You don't have to do anything for that.
Yeah.
You just have to tell it it's associative.
Mm-hmm.
And then finally, there are new use cases where so the definition that we saw earlier, we talked about unified streaming and batch data processing. That is specifically with regard to the tool set. The vernacular, the tool set, a lot of the code is exactly the same in terms of writing streaming of pipelines or batch processing pipelines. And technically, you could even put them in the same pipeline if you wanted to. I haven't seen a real world case where that would be needed, but you could.
Yeah.
It's definitely possible.
Yeah. So I think, I mean, just to kind of close off on the question, right?
Sure.
I think the intent between Spark and Beam, I think it's similar, but there's a difference in a sense that actually there's a really good example in the link that we just sent, which shows you how much code is required to write one function versus another. And it's about, maybe 1/3 or even 1/4 the length of code. And of course, you can do any of this in Spark, but the goal here with Dataflow is to simplify your life, focus on writing valuable applications and not, writing extra code. I think it's really, yeah. Go check out the link, Richard. I think if you have additional questions, let us know. But it's a very thorough and in-depth analysis of Spark versus Beam. But that's a great question. I'm sure a lot of customers have the same question.
Yep. And I think the question came up last week that you could run this on top of Spark. There is a Spark runner that you could run this on if you have a cluster laying around and you want to make that happen. We'll use the Dataflow runner in the live example because I didn't have a Spark cluster laying around. But if you had one, you could use that.
Yeah. So I mean, David's been talking about Apache Beam this whole time. If you use the open source version, then you definitely need to set up your own infrastructure, whether it's like a Hadoop cluster with Spark on top. But with Dataflow, you just write the code and you send in, basically send it into the API, and that's it, right? We set up all the infrastructure for you, and there's no management of that infrastructure.
Speaking of using Apache Beam, see that segue? See how I did that?
You're awesome.
All right, now let's talk a little bit about what it takes to use Apache Beam. Now, before we get going, there is a decision that we have to make. And that decision is based around the language. On the one hand, you have Java. Dataflow and Apache Beam are built around Millwheel and Flume Java of the same name. Those papers, which you can go read if you are inclined to get really deep into the weeds on that stuff. And then on the other hand, we can also do this in Python as well. The Python SDK is in beta. There are some trade-offs with going to one side versus the other. Java has everything built in and batteries are included and it's ready to go. Python is still working on streaming support. But at the same time, to me, I find that Java is really verbose, and I don't happen to already have Eclipse installed on my machine. So today I'm going to walk you through some of the basics in Python so that we can get a sense for what a Dataflow pipeline may look like in code. And you could relatively I think if you're a Java person, you'll be able to take it away from Python. And if you're not, the Python syntax is a lot less daunting. Basic concepts to know before we get started are simply 4. Number 1, everything that is done in data pipelines are based on P collections. So this is short for parallel collections, which are just groups of different data items that can be operated on in parallel. They are immutable, so you don't mutate them. Instead, you write functions that take a P collection and output a new P collection. The functions that you write are of the form of Pardue, or in Python, we tend to write more map and flat map just for succinctness. But like I just said, it's a function that you write that takes in a p collection and outputs another. Group by key is important because oftentimes you want to group together data with some sort of meaningful alignment, and that's what you're going to do with a group by key. And then the fourth one I'm going to recommend is combiners. So combiners are a set of pre-built functions inside of Apache Beam. And they come with all those nice associative declarations, so you can get a lot of those optimizations out of the system without having to do anything. And also, you don't have to rewrite your own sum function and various other things like that. So this is the point where we get to try it out live. Who's ready for this?
That's dangerous. I don't like it.
There's only one way to do this.
Living on the edge, David.
So diving into the Google Cloud Console, which is where I am here, what I'm going to do is I'm going to boot up my Cloud Shell. So for those who are not familiar, you get a free little micro instance with a lot of dev tools built in just whenever you need it inside of Cloud Shell. If you want to access some things via the command line and you may not have a terminal handy, for example, I'm currently doing this on a Chromebook, so there is no local terminal. But
here's a shout out for Cloud Shell, by the way. Cloud Shell is super cool.
Oh yeah, we're gonna, yes. I do this all day, so I'm a big fan.
Yeah.
Now there are two lines that we have to set up here in order to get running with Dataflow on our little instance. So first is we're going to upgrade pip, and that has nothing to do with Dataflow, but otherwise it complains a lot more if we don't do that. So first thing I'm going to do is upgrade pip. Now the second thing that I'm going to do is I'm going to install the package. So sudo pip install.
So by the way, for those listening, so Cloud Shell is almost like a miniature instance that you get as part of your experience with Google Cloud, and it allows you to run commands and build a small mini programming environment so that you can access your Google Cloud instances.
Yeah, it's a mini instance you get for free, and one of the nice things it does is it persists your home directory. So if you are, I don't know, building a demo for people on a webinar, then you could write some code in advance and it'll still be there later. That's kind of nice. But you could also use it as sort of, again, I'm on a Chromebook, so I actually use this as my toy programming environment when I'm on the run. But there are a number of other use cases that you could use it for too.
Yeah, it's an alternative to actually
so now that
installing.
People can see this. I'll make this bigger.
Yeah.
That looks
good.
That looks comically large. All right. Into the directory that we care about. So got a couple of different files inside of this directory. Let's go ahead and get rid of the outbound one. That was, of course, from running things earlier. Now, the one that I'm going to want to start by looking at is the minimal example here for min.py. Now, I'm actually going to use a code editor that is built into Cloud Shell. So we have our own deployment of Orion that you can get up and running that will actually plug directly into the file system that you have on your Cloud Shell machine. Unless, live demo time, are we making it work? There we go. So here you can see everything that I have in my home directory on that machine, and this is the directory that we're talking about. So the first example that we're going to walk through, talking about Apache Beam and building pipelines, is this one. So this is pulled from, this is a modified one that I have from the minimal example that you can find in the public repo. Now, there's a lot of code here up at the top, and again, the emphasis for today is on approachability. So you can ignore all of this stuff. This is all basically just argument definition things. And I apparently am not as good with argparse as I thought I was. So I was trying to mess around with it at first, and then ended up just like dumping a bunch of it in there by hand at the bottom. So don't worry about any of this part is what I'm trying to say, because that's not material to what we're talking about today. Instead, everything that you need to write a perfectly functioning pipeline is here at the bottom. So first, we are going to instantiate the object with the options that have been passed to it. So nothing sophisticated there. The actual work starts down here, and I'll walk through the syntax piece by piece. So the syntax is very much along the lines of some other languages that allow you to pipe in values from one to the next. So we're going to use the pipe operator here to take that pipeline object, give it just a label here. This is all this label is doing. And then pass in that pipeline to a function. So in this case, we start with reading from a text file that happens to be a sample from King Lear. And we're going to do a basic word count example here for the start. From there, you can see we store that in, there's not actually a nomenclature for this that I'm aware of, but I call this a checkpoint. It's just a point in your pipeline that you can use to start a different branch if you want to. So you can see here we started with our pipeline and fed it into lines, and then we're going to take lines and put it through a few steps. So lambda is just an anonymous function where we are reading all of the different words that match this regular expression and then piping it out as Unicode over here. And we put that through flatmap. The brief aside for flatmap is that each of the lines of the text file is read in one by one. And if we did not use flatmap, you would get collections of lines as a single item. So you get like a two-dimensional array, whereas flatmap flattens all those things together. So you just get the one-dimensional array of all the different words. The next step we do, sort of doing this in true MapReduce fashion, is we're going to do map where we put a 1 next to each one of the words, and that will actually now create that two-dimensional array of the, or key value pair of the word and then a single 1. We're going to group them all together so that we can see, get all those pieces in one spot, and then we are going to actually sum them up with one last map. Now that's all the hard stuff, and then is followed by this last bit here where we are formatting the output to have a colon, because I guess colons are like top tier of data format output, I guess. And then we're writing it to a text file. So 1, 2, 3, 4, 5, 6, 7, 8 lines of real pipeline code that are needed to get up and running.
Could the counts actually be one line?
Oh, we'll get that. We'll get there in a bit. Yes. So if we wanted to run this locally, that's actually really easy to do. All we need to do is give this the argument, and I'm actually going to give it an output file. So we're going to call this output because I'm really creative. Now you can see what this is doing is running the pipeline on the direct runner, which means the Python on my machine is processing this pipeline and running through the output that it has, grabbing these local files here. If we go back out here, we can see we've got that output file. And if we cat it, then we've got all those nice little colon separated values there. Now, running things locally is great, but we may want to run these in the cloud for obvious reasons.
And you might have a bigger data set.
You might have a bigger data set. We're not going to use a bigger data set in this example for just because ease and stuff. But to show you how easy it is,
if you can run it on your laptop, then you probably don't need Dataflow.
That's true.
Just being honest. So,
but if it is very easy to change. Yeah. So you'll notice here, all I have to do is change which runner.
Yeah, that's amazing.
Is doing on this, and then I can literally just rerun this. So you'll notice that not only are the messages different, but it's starting to work with, that's another pip thing, because even upgraded pip still isn't good enough.
There you go.
And what that's done is it's actually taken that pipeline, uploaded it to Google Cloud Platform, and now makes it available and running inside of the background inside of Google Cloud. Now, we can see the job in process too. So if we go over here to Dataflow, we can see the list of all of the jobs that I have been doing in preparation for this. And if we pop into the current job that's running, you can see each of the different labels that we had in our pipeline over here. So read, extract words, pair with 1. All of those each come to different sections of this graph that we can understand, dive into, get a little bit of details about, as well as just get details about the entirety of the pipeline and figure out what's going on.
Right.
Other things that are worth mentioning is that we actually did not specify how many workers we wanted. Our Cloud Dataflow service figures all of that out for you so that it will scale them up when you have more data coming in, depending on different scenarios, and it will also scale them down on different scenarios as well.
We have a quick question from Alan. So is Dataflow a good tool to do batch processing on binary data, video files, image processing, extract metrics from that, and do transforms on the same binary data?
That's a great question. I have not seen anyone doing any work with binary data inside of Dataflow. So I'm not going to say it's not possible because I figure there's got to be a library out there somewhere.
I mean, Dataflow doesn't discriminate, right? So if there's certain things in those files,
the fundamental paradigm of it shouldn't discriminate, but it'll. The short answer is that I haven't seen it, but I don't know.
Okay.
Now you did mention earlier, and you can see here how many workers are getting spun up in order to handle this. Now you did mention earlier, Jonathan, that you thought we could handle this more efficiently, and I don't disagree. So what we're going to do over here is we're going to comment out a few of these lines that were more MapReduce style. So now the one that we've kept here is getting all of the words with our regular expression. And then we use, once again, I mentioned the combiners. So you can just say, count these up per element. I don't really care how you do it or when you do it and everything else. So from there, we'll go ahead and give this a second name. Let's call this word count min2 because we're, again, at the height of our creativity here. And if we run that one instead, that will push that job up to Cloud Dataflow. And if we look at our list, we can see that it'll have changed our graph, right? So we've just got read, extract words, run this per element. And if you want to drill in, you can see some of the steps that are going on under the hood there if you're interested. But otherwise, you've got increasing levels of sort of simplification that you can use on your pipelines. Now, this is also the most basic pipeline. It goes from top to bottom. The inputs from step 1 and the outputs from step 1 go to step 2, and it's very linear in that regard. So I also wanted to give you guys an example of what it would look like to see what a branching pipeline looks like. So a branching pipeline.
Can you describe the differences again?
Sure. So because you are building a graph, you can take inputs and outputs from any of the different functions that you make and rearrange them together in different styles of pipelines. And I actually think a concrete example is going to be the best way to take a look at this. So in this example, we are taking 3 different files which have names and phone numbers, names and emails, and names and addresses. And we're going to combine the data together that has combinable data. And we are going to slough off we're going to basically make lists of making fun of people if they don't have an email address and stuff like that. So once again, all of this is argument-based stuff. You can safely ignore it for the sake of instruction. We're declaring our pipeline here, and the actual stuff where things happen is right here. So this is similar to the syntax we saw earlier, where we're taking the pipeline and then feeding it through with a label to each of the different functions here. So this is just mapping to escape the backslashes, to escape the quotes, and to extract things by tabs, because we have tab separated value things. The cool thing about saving it in a function is that we can reuse that for each of the different things that we want to do. So to take a look at this definition and then use it here, you can see that we are actually running these stages of the pipeline for each of the different files that we have for our email file, our phone number file, and our snail mail file. So at the top of our graph, we're not going to have one source that starts. We're actually going to have 3 different sources that start. And then we group them all together here. So you can see we're grouping by key so that we can get them together by name. And we are, once again, formatting them together in a tab-separated way, because tab-separated values are apparently the way of the future. And here's where a little bit of fun that we're having, where we're, in addition to having the output where everything is put together, we're also going to put together some of the Luddites, people who don't have emails, and people who don't have phones, and people who don't have addresses into different sections as well.
That's pretty mean.
It's all in good-hearted fun, I think, Jonathan.
I don't think my grandma has an email.
And so again, we use a combiner to group them all together and write them to the appropriate output. So let's test this locally first. I actually wrote a bash line because I was worried I was going to mess up typing this out. You can see basically I just added in the parameters. So if you'll believe me that I didn't do anything magical, and go.
Yeah, David's got fat fingers, so.
Yeah, I do have fat fingers. That's true. So here we can see that our output TSV is the output piece that we wanted here. And that would be the combination of all those different names and numbers and outputs. So if we did cat emails just to see what that looks like,
Very cool.
you can see we've got the different names that go in here, and we've got them all pushed together here. And it doesn't take long at all. But then if we want to push this up to the clouds,
The intertubes.
the intertubes across the information superhighway. All we got to do is run this. Takes that same code with the same parameters that I typed in there, except it's actually pulling from cloud storage, which has some of them that I put there. Pushes those up to Cloud Dataflow.
Yeah,
And
that's good stuff.
the resulting data flow looks something like this.
Fantastic. Look at that.
So not totally sure why these lines are being crossed here. Graph drawing, always a fun subject. But you can see here that we've got basically separate columns for how we're processing each of the different emails.
Are those considered branches?
They are different branches, you're right. Grouping them together here so that we can actually join them in a way that we want. And then we can output into 4 different sections here, the TSV and the appropriate making fun of pieces down there at the bottom. So there's a lot of opportunity for mixing and matching. You can have side inputs, you can have side outputs. There's just a lot of different directions that you can go with building your pipeline, and it all comes together sort of in that graph view. The last thing that I will say about this is I'm sure some people noted, because we have an audience that I'm sure is very astute. You will note, if we can go back far enough, how much history do I keep in my terminal? These are real questions.
Oh, I'm sure most of our audience is smarter than us.
Oh, well, that's not in doubt
That's
at all.
without a doubt.
Yeah. All right.
Well, maybe smarter than me. I won't say you.
Yeah. Let's just do this one again so you can see. Oh, it's re-uploading it to Dataflow because I forgot to change the.
So while David's doing that, I think one of my customers, and this is more of a business question that he had, is, I mean, all these technologies that we have are great in terms of, hey, we can spin up thousands and thousands of cores behind the scenes and run your job, but what's it going to cost me, right?
Mm-hmm.
And I think with Dataflow, we do have a kind of prevention mechanisms to prevent you from spinning up thousands of workers. I think you can limit the number of workers within Dataflow, so you're not using too many resources. Yeah. So.
Yep. So astute viewers will notice that the local pipeline runner took 1/10 of a second, and that some of the runtimes here for the Cloud Dataflow pipelines that we pushed up here are running in the several minutes range.
Wow.
The reason for that is there are 2 reasons for that. One of which is that everything is already instantiated on my local machine. So most of this time, if we actually dive in here, you can see that this basically ran for a couple of seconds. So most of the time that was devoted to getting this cluster spun up was eaten into that time. The second thing is that the Python SDK is still in beta. So it's not quite as efficient as the Java one. The Java one has slightly less overhead in terms of getting the cluster and stuff set up. I see on average, it takes about 2 minutes to set up a pipeline somewhere in there. And that's before you're doing any meaningful operations, right? But Python, for some reason, takes a little bit longer, and I haven't had a chance to sync with the team to figure out why that is. I assume it's because this is beta.
Okay. Oh, no, thanks for calling that out. I mean, I didn't notice it because I wasn't looking at the time, but I think that's important to know is if your job is running within minutes on your local laptop, then you probably shouldn't be running this
in any type of Hadoop environment.
Yeah, when we're talking about big data,
Yeah.
we're talking about
like terabytes. And petabytes.
like hundreds of terabytes,
Yeah.
petabytes type stuff.
Right.
That's things that you can turn on and leave running for significant amounts of time on large clusters. So there is some overhead associated with doing things on multiple machines, and that's sort of the nature of the business. Now, I will say only, because I think you're about to jump in with a question or two.
Yeah.
This is the part that I planned for questions. That's everything that I had
great.
set up to show you today.
That's good. I'll give you a high five.
High fives.
That was good. I had low expectations for David.
Oh,
that
thank
was
you.
actually very good. Very, very good.
Okay. Well, I appreciate that, Jonathan. So here, if you guys have any questions, I would be glad to field some of them from the chat. The best place to go and learn about Cloud Dataflow right now, and this is true, we have some documentation on our website that run through some pretty good examples and explainers, particularly on the streaming use case of how to make use of some of the concepts that I didn't go over today, whether you're talking about windows or watermarks or things that essentially transform streaming data into backable subsets. That's a cool topic that's totally for a different day.
Yeah.
But the best way to go and learn this stuff by far is to actually go browse the source repo. So
there's a lot of examples there, right?
There's a lot of examples there. So
that's one way.
I would search for Apache Beam Python, and for some reason the old Dataflow Python package still comes up. So if you jump into the official Apache Beam, I could start pronouncing it that way.
Yeah.
You can see in here there's a folder of examples. Some of these are the minimal ones that we just talked about. And then the cookbook has a lot of actually good ones here too that show you some of the different more advanced concepts on Dataflow as well. And reading the code is honestly probably the best way to do it. And I think Python is the most approachable way to do it.
I also sent the code labs. I mean, that's in general, if you want to learn about the technology, we have a website where we have step-by-step, can't mess up tutorials where you just copy and paste lines of code and press submit, and you get to see how it kind of all works behind the scenes. For someone like myself, just playing at a high level, and it's really useful to understand. But yeah, I mean, I guess, I'll use this time. We have a couple minutes. I mean, how are you seeing customers? What are some interesting use cases that you've seen customers use Dataflow in? And I can give my anecdotes.
There are a lot. So the example that we talk about a lot in a theoretical sense is with gaming. So if you are trying to process like events from a mobile game, which may come in at different points in time and may be ordered or may be unordered, you need to find a coherent way to handle all of that data, complete with data that comes in late as well as data that comes in on time. And depending on your use case, you may want to get that up and run it, or you may want to treat that late data differently, right? Because maybe you have thresholds at which point it doesn't matter, or maybe you have cases where you need to be continually updated and you need to sort of rerun systems like leaderboards or something if you get data that comes in late because someone was going through a tunnel or something. So there are a lot of potential applications on that side. What are some of the examples you're thinking of?
Yeah, well, actually, so here's a good question. So Columetta asked, and I'll get back to the example, what if a node crashes? We handle that failure on the back end. Right?
Correct. So with the Cloud Dataflow runner, you are not in charge of making sure the nodes figure everything out. That is our job.
You probably won't even notice if a node crashed.
One of the things that's also cool about the service is it will dynamically scale them down if it misestimates what your work is. So it's not like it estimates your cluster size and then goes.
Right.
It actually re-estimates the work that it has left over on nodes. And so if some of them get hung, it will actually take the work that's assigned to them and repartition it and split it up against other nodes.
And that's in real time with no configuration.
Right? Yeah, you don't do that. The system does that. It's this whole idea of, it's kind of like the bridge where we're talking a lot these days about code as configuration as code, where you can make a statement and then your system will run and try and figure out how to create that state for you. Kubernetes is like this, right? Where you tell it what kind of world you would like to see, and it figures it out even if something goes up or down. Dataflow is very similar in that you tell it the processing pipeline you would like it to perform, and it figures out how to make that happen and to go through it.
Right. Okay, that's good. Yeah, I mean, so Columetta, I mean, we'll see if we have any information on the persistence model, but I think the way that Dataflow works is that if a node crashes, you won't even notice, and it's all abstracted from you. So yeah, I think it's that simple. Mario asked about examples using Dataflow for machine learning. And Anthony, thank you for suggesting that. And that's exactly what I was going to say is I do have some customers who are using Dataflow for pre-processing information, meaning Dataflow wouldn't necessarily be doing the actual machine learning and training for you. That's something where TensorFlow really shines. But Dataflow is really good at taking all this information that you have and setting up your data, right? And if most machine learning experts or specialists will say that the most difficult part of machine learning is getting the data labeled and getting the data prepared and deciding what data to use for training and learning. And so Dataflow is really good about, okay, you have all this information and you want to set it up and frame it up in a way that you have a specific schema that you want to follow when you dump in all this data into your machine learning platform. That's what Dataflow is really good for. But for machine learning itself, I'm sure you could probably hack it to do some kind of machine learning algorithms, but it's really not the best use case for that. And that's where Cloud ML would be good. So a simple workflow would be something where you have data coming in from Dataflow and maybe storing it into a bucket, a storage bucket, and that storage bucket would be called out by Cloud ML, which is our hosted TensorFlow learning platform, to start training and learning from that data. So hopefully, Mario, that answers your question. And then another interesting use case I've seen Dataflow for is we're working with a venture capitalist, and they invest in very small early stage startups. And with these early stage startups, it's very hard to measure how well they are doing with their business. And what they've done is they've used Dataflow to collect a lot of information from social networks, from websites, and it just goes out and grabs all this information, parses it in a way that they can quantify how well a business is doing as a startup. And that was a really interesting use case for Dataflow that I had never thought about at first.
Okay.
Well, yeah, I guess that's it. Well, thanks for all the great questions. I think, Dataflow, we mentioned is intimidating, but it's actually, once you take time to look at it, it's very easy to use. I always say if David can learn it, anybody can learn it.
Hey, yes, that's technically true.
Hey, I say that about myself as well. So
I don't know if there's anything else you want to mention before we hop off today.
No, I mean, I guess another question that a lot of customers ask is when do I use Dataflow versus Hadoop, right? And that was something I was going to have another online meetup for, because there's a lot of best practices around when to use either. But at a very high level, I think if you have a brand new big data job, I think the best thing to do is to use Dataflow. If you have existing Hadoop code, existing MapReduce code, then you can use our Dataproc, which is our managed big data / Hadoop cluster that you can run your code on.
Yeah, I think that's fair. Greenfield projects, Dataflow is a good fit.
Yeah.
But if you're looking to port some of those big workloads that you don't want to dive into too deeply, you could always go with Dataproc.
Right. Exactly.
I was thinking more general announcements. For example, I will be at GDC for the next few days. So if anyone out there is listening and will happen to be at GDC in San Francisco, then I will be on the floor very interested in meeting you and shaking your hand and saying hello. I'll be at the Google Cloud booth, but
That's great.
I don't know if there's anything else.
No,
Yeah.
that's great. Thanks for sharing that. We'll also be at our next conference. In
Oh, is that
2
coming
weeks.
up?
Yeah. That is coming
Yeah.
up. You signed yourself up to be a booth expert. So
Oh, that's right. I'm going to be on the floor there
yeah.
too. Yeah.
Yeah. So we'll be there in 2 weeks. Definitely come by and say hi. But yeah, we're looking forward to seeing everyone. And until next time, you can always reach us on our Meetup group. And as always, we're always happy to take any questions and suggestions for next online meetups.
Right. If you have further questions on Dataflow, probably the best place to go would probably be the Slack channel.
Yeah, Slack channel. Slack channel. You can always email this group for simple questions. We're not tech support, but we'll definitely point you to the right place.
Yeah, glad to try.
Yeah.
Thanks for watching, everyone. Otherwise, and
have a good day, good evening, good morning, wherever you are. Thank
wherever
you.
you are.
Wherever
Take care, everyone.
Take care.